Hello and welcome to our lesson on three-dimensional figures. So we have a lot of vocabulary to start with. First, a solid. A solid is a 3D, so 3D is short for three-dimensional, a 3D figure that encloses a space. So all six of these are solids. They all enclose a space. And now these last three are considered polyhedrons. These are special solids, and these are solids whose faces are all polygons. So each of the faces of the 3D figure is a polygon, so that makes it a polyhedron. So we're going to focus on two types of polyhedrons, prisms and pyramids. So what makes something a prism is that it's a polyhedron with two parallel identical bases and lateral faces that are quadrilaterals. And we're going to look at lateral faces that are rectangles. That's what we're going to focus on. So there are many types of prisms. And as it's stated, you need two parallel bases that are identical. So in this case, we have triangles, which are our identical bases, and those are parallel to each other. And then what connects the bases are rectangles, and those are our lateral faces. So we have one kind of on the back left, one on the bottom, and then one on the right hand side. So those are prisms, and we'll look at a few of those in a minute. And then we get to pyramids. So pyramids, again, are polyhedrons, but they only have one base. And the lateral faces are triangles that share a vertex. So here's a pyramid. Notice it has one base. It does not have another base that is parallel to it. And then notice we have a vertex. Here's the vertex that is shared by the lateral faces. And those lateral faces, so we have the left, the back, the right, and the front, they are always going to be triangles. Now, prisms and pyramids are named based on the shape of their base, as you can see from these examples here. So if your bases are pentagons, then you're going to have a pentagonal prism, or if it's a pyramid, a pentagonal pyramid. So these are just examples, and you can see there are many different types of prisms and pyramids. So let's try and name these. Okay, so the first thing I like to look for is, do I have one base or two bases? That'll tell me if it's a prism or pyramid, and then I can figure out what is the shape of the base to help me name it. So this first one, I do have two parallel bases that are identical on the top and the bottom. So I know right away this is a prism, and the shape of those is a triangle. So this will be a triangular prism. Next up, my next one, again, I see two parallel bases. Actually, there's three sets of parallel bases because it's rectangular, but I'm going to use the top and bottom. So again, I have parallel bases that are identical, so it's a prism, and they are rectangles, so it's a rectangular prism. Now our next one, there is only one base. There is not a parallel base to it, so I know right away it's a pyramid. And the shape of that base is a triangle, so it's a triangular pyramid. And notice the triangular pyramid has triangular, so all pyramids have triangular lateral faces that share a single vertex. And last but not least, again, we have another polyhedron with just one base. So it's a pyramid. And this happens to be a six-sided base, which makes it a hexagon. And we call it a hexagonal pyramid. And again, we see the triangular lateral faces that all share a common vertex. Some more vocabulary for us. We have what are called faces, edges, and vertices, or in singular form is a vertex. So the faces are the surfaces, so face is like short for surface, are the surfaces of the polyhedron. The edges are the line segments that connect two faces, and the vertices, or singular vertex, is where three or more edges intersect. Now you're going to be asked to identify the number of faces, edges, and vertices for our different prisms and pyramids. And without holding one, it might be hard to actually visualize these three-dimensional shapes. So there is a website, and one link is for prisms, the other link's for pyramids. And the website's really nice in that it will allow you to manipulate pyramids and prisms. So here is the pyramid site. And if you scroll up, when you first go to the site, you'll see some information about pyramids or prisms. Then scroll down to the interactive side. And if you click and drag, you'll actually be able to manipulate the pyramid. If you kind of drag and let go, it'll be spinning. And then you can use these buttons down below to highlight the faces, the vertices, and the edges. And that might help you as you are asked to count the number of faces, edges, and vertices to go to this website and check that out. Okay? And there is also one for the pyramids, for the prisms as well, so you can click on that link, or you can type it in. All right, so let's go ahead and jump back and look at our first shape here to identify the faces, edges, and vertices. So I know I have two parallel bases, so it's a prism, and they're both rectangles. So we have a rectangular prism is the name of this shape. And now I need to count the faces, edges, and vertices. And I actually kind of like to go backwards. It's kind of up to you how you do it, but I like to go backwards and start with the vertices. So the vertices, I usually count the vertices of the base first, then the second base if it's a prism, and for vertices, that's all that there is. So I'm going to go ahead and count 1, 2, 3, 4. So I have 4 vertices for my one base, and then I count the other base, 1, 2, 3, 4. That's 4 more, and that gives me 8 total. And what you'll find with prisms is the number of vertices will always be twice the number of vertices of the base. So if you have a pentagonal prism, which has 5 vertices, then the number of vertices for the entire prism will be 5 plus 5 is 10. All right, the next thing I like to do is connect the vertices, and that will give me my edges. So again, using the base, my first base, there's 1, 2, 3, 4. For my first base, there's 1, 2, 3, 4 edges. For my second base, now I also need these edges that connect my bases. So there's 1, 2, 3, 4 more, which gives a total of 12. And notice the number of edges for a prism is always going to be 3 times the number of edges of your base. And then finally for the faces, again, starting with the bases, I like to count the bases first. So I've got the top and I've got the bottom. So I'm always going to have 2 bases for a prism. I forgot to write the word prism up here. Sorry about that. And then I'm always going to have lateral faces to connect the 2 bases. And the number of lateral faces is always going to be the same as the number of sides of your base. So if I connect these, I'll connect the back as 1, connect the right is 2, connect the left is 3, connect the front is 4. So notice my base has 4 sides, so I need 4 lateral faces to connect our bases, and that is 6. So for the faces of prisms, it's always 2 more than the number of sides on your base. All right, let's look at the next one. We again have 2 parallel bases, so it is a prism, and our bases are triangles, so it's a triangular prism. If I connect the vertices, I'm going to start with the bases. 1, 2, 3, 4, 5, 6. So I have 3 vertices for one base plus 3 vertices for the second base gives me 6 total. Let's go ahead and connect these vertices. So first our bases, 1, 2, 3, plus 1, 2, 3 for the back base. Now we need to connect our bases. 1, 2, 3 to connect our bases. So we have 3 for one base, 3 for the other base. 3 to connect the bases is 9 altogether. And now let's look at our faces. Our faces, again, go with the bases. We have 1, 2. So we have 2 faces, which are our bases. And then we have to do our lateral faces, which connect the bases. I know a lot of vocabulary. So I'm going to do the right, the left over here, and the bottom. Right, left, and bottom is 3 more, and that gives us 5. Moving on to our next one. We only have one base, so we know it's a pyramid, and that is a triangle. So it's a triangular pyramid. Using the same method of attacking the vertices first, going for the vertices first, we have 1, 2, 3 vertices for the base. And notice for a pyramid, there is 1 more vertice for that shared vertex of the lateral faces. So plus 1 more equals 4 vertices. Now connecting our vertices around the base, we have 1, 2, 3 edges that are connecting our vertices on the base. Now we need to connect our base to that shared vertex. So we have 1, 2, 3 edges to do that, which gives us 6. So the number of edges is always going to be twice the number of sides of your base for pyramids. And last but not least, we need to count the number of faces. We have 1 base, so 1 base, plus the lateral faces that will connect us to our top of our pyramid. So we've got the back in this case, and then we've got the left front and right front. So that's 3, which gives us 4. So the number of faces is always going to be 1 for the base plus the number of sides of your base, because that's the number of lateral faces to connect to the shared vertex. All right, one last one. Another pyramid, because we have 1 base, and that base is a square. So a square pyramid. Counting the vertices, we have 4 for the base, plus 1 more for the shared vertex. So 4 plus 1 gives us 5. Now looking at the edges, connecting the vertices to make our edges for the base, we have 1, 2, 3, 4. Plus we need the edges to connect our base to the shared vertex. 1, 2, 3, 4 more gives us 8. And finally the number of faces, we have 1 for the base, plus we have to connect our base to that shared vertex. So we have 1, 2, 3, and 4 lateral faces. We have the back, the left, the right, and the front gives us 5. And you may notice that the number of faces and vertices for a pyramid will always be the same. All right, so take your time with this. It will take some visualizing. So again, if you can, you should have a website link or website links to the website with these virtual manipulatives. It might help you in investigating the shapes more. All right, that'll do it for today.